Example 5. Let fx is equal to 20x squared minus p, where x less than 4, q where x equal to 4, and px cubed minus 5 where x more than 4. A. Find the value of p such that limit of fx as x approaches 4 is exists. Hence, find the value of q such that f is continuous at x equal to 4. So, for the part A, we need to find the value of p, and given limit of fx as x approaches 4 is exists. Then, for the part B, we need to find the value of q such that f is continuous at x equal to 4. So we solve for the part A first. Step 1. Understand the problem. In this question, it's mentioned that limit fx as x approaches 4 is exists. Step 2. Devise a plan. So, to find the value of p, we can look at one of the conditions to be continuous, which is limit of fx as x approaches a exists. We will determine the stated two-sided limit by first considering the corresponding one-sided limits. For each one-sided limit, we must use the part of the formula that is applicable on the interval over which x varies. For example, as x approaches 4 from the left, we can see that as x approaches 4 from the left, the applicable formula is 20x squared minus 20x squared minus p. Then, when x approaches 4 from the right, the applicable part of the formula near 4 is px cubed minus 3. This is applicable formula for x more than 4. So we carry out the plan by using the condition, which is limit of fx as x approaches a is this. So the limit of fx as x approaches 4 from the left is equal to limit of fx as x approaches 4 from the right. We put the applicable part for the formula. For the x approaches 4 from the left, the applicable part of the formula is 20x squared minus p. And then for the x approaches 4 from the right, the applicable part of the formula near to 4 is px cubed minus 5. So we solve the limit, each of the limit, where we substitute the value of 4 into the formula. So for the left hand side, we get 20 multiplied by 4 squared minus p equal to p 4 cube, p multiplied by 4 cube minus 5, and we simplify, we can get negative 65p minus negative 325. So we get p equal to 5. So this is the value of p that we got. And then we check the answer in the step 4, where we can substitute the value of p equal to 5 into the function and prove that the condition of limit of fx as x approaches 4 is exists, like it's mentioned in the question. So to prove that, we substitute p equal to 5 into the function, and now we substitute the value of p into the function. Okay, this is the value of p. So we check the value of limit f as x approaches 4 from the left first. We use the applicable formula as x approaches 4 from the left, which is 20x squared minus b. And we solve this limit and we got 315. Okay, then we solve for the limit fx as x approaches 4 from the right. And the applicable formula for this limit is 5x cubed minus 5. Okay, then we solve this limit and we also got the same answer, which is 315. So we can conclude that limit of fx as x approaches 4 from the left is equal to limit of fx as x approaches 4 from the right. Thus, prove that the limit of fx as x approaches 4 exists. So we move to the part B. For the part B, step 1 is understand the problem, where in the question is mentioned that f is continuous at x equal to 4. For the step 2, we devise a plan. As we know, a function f is said to be continuous at x equal to a, provided the following conditions are satisfied. It has 3 conditions. The first condition is fa is defined. The second condition is limit of fx as x approaches a exists. And the last condition is limit fx as x approaches a is equal to fa. So we carry out the plan to find the q, where we use the third condition, which is limit of fx approaches x as x approaches a is equal to fa. So a we replace by 4. Okay, like this. So we solve for the limit fx as x approaches 4 from the left is equal to f4. So the applicable formula for the 4 as x approaches 4 from the left, the applicable formula is 20x squared minus 5, and f4 is equal to q. So we solve this limit and we got the value of q, which is 315. So it is the answer for this part. And to check the answer in step 4, given that in the question where f is continuous at x equal to 4, so we can check the answer by determining the continuity when x equal to 4, and we substitute the value of q equal to 315 into the function. Okay, here is the piecewise function where we just replace the q equal to 315. Okay, we check for the first condition, which is fa is defined. So for this question, a is equal to 4, so f4 is equal to 315. Thus fx is defined. We check for the second condition, where the limit of fx as x approaches 4 from the left equal to limit of fx as x approaches 4 from the right. So we solve for the x as x approaches for 4 from the left first, and we got 315. For the limit of fx as x approaches 4 from the right, we also got the same answer, which is 315. So we can conclude that limit of fx as x approaches 4 from the left is equal limit of fx as x approaches 4 from the right. So the limit fx as x approaches 4 is equal to 315. Thus, limit of fx as x approaches 4 exists. The last condition is limit of fa as x approaches a is equal to fa. So for this question, we know that the limit of fx as x approaches to 4 is equal to the fa, which is the answer is 315. So we can say that fa is continuous at x equal to 4. So prove that fx is continuous at x equal to 4 when the value of q is equal to 315.